Hey, and welcome back. So I want to move the vertical spindle back in relation to the y-axis travel of the table. More specifically, I want to be able to get the vertical spindle over this slot and be able to do work from the vertical or the horizontal spindle without changing my part setup. Before I took the machine apart the first time, I took a measurement of where the ram was located at, and I thought, hey, I'll just put it back where it was at. That's a good place to start. And of course, depending on your vise or what have you, your location is going to change. So I need a different method for tramming the table, because this is what I did whenever I originally set it up. And let me tell you, that's a very slow and tedious process. There's got to be a better way. I'm not too worried about getting this super dialed in perfect at this point. I just want to get it close. This is a drop from a machine shop auction lot, and so I have very little invested in it as far as that goes, but I don't know what kind of material it is. What I do know is that it's very happy to run at 325 RPM, and that's it. It didn't want very much more RPM, although I could get away with it for a finish cut as long as I decrease my depth of cut. And I could play with the feed rate quite a bit, but the RPM, that was pretty much all I could do with it. Just a little trick that I figured out for doing chamfers, although on this part it doesn't matter a whole lot because of the large diameter, but on this tool post I have another CNMG insert holder that is for the south bend lathe, and I just have it reversed in the holder. So when I want to do a chamfer on a smaller diameter part, I can just change over real quick, and it's very near the same position. I just have to move forward towards the part a little bit, and I'm right there. I don't have to move off axis very far, and I'm doing a chamfer and on about my way instead of doing a bunch of work with the wheels. At this point, I have what will be the bottom of the part faced off, and as you saw in the beginning of the video, I just started on this side because of that really rough bandsaw cut. I've also created a pocket there, which will be to mount it to the 3-jaw chuck so I can true up the OD, as well as be able to true up the face on the top side. Any idea what that's shorthand for? If you do, let us know in the comments below, as well as CC. Once I got the OD trued up on the 3-jaw chuck with some light passes, I switched back to the 4-jaw chuck for better work holding while I get this top face roughed in. At this point, I'm pretty well trued up, but I'm still out by a little shy of 1/1000th, so around 8 or 9/10, and I need to get it better than that. So I switched back to the 3-jaw, which is the reason for the pocket, and commenced to doing this. That's the best resolution indicator that I have, so this is rather time consuming. I really need to invest in getting a 10th indicator, but they are quite expensive. I only indicated in on the back side of the part since I'm going to recut the face anyways. Alright, with all the cutting done, you can see on the back side of the part, I'm still looking really good, maybe 1/10 out. And then this is the front face or top face, and you can see I'm out by maybe 2 or 3/10, and you can also see that here on the mic. Alright, let's take a break from the big metal disc for a minute and check out this Delrin. So that's like 150 thousandths depth of cut, so 300 thousandths off of the diameter. And that was strangely satisfying and a lot of fun. That's a piece of a drop that I just picked up recently for like next to nothing, so I got no problem with whittling it down to next to nothing. And hey, if you want to make high quality plastic confetti, well, there you go. Alright, so what's this Delrin sleeve about anyways? I need to make an adapter between this tool post holder, which is for MT2 sleeve or for a boring bar if you custom make it, and die grinder that I found at Harbor Freight. I think it just came out recently. It's got a 4-inch extension shaft on the end of it, and the shaft is larger than the collet is on the end, which will make sense if you've used a die grinder before. You know that most die grinders have a neck down shank, so that would be kind of difficult to clamp onto or hold onto. You could do it, but it wouldn't be as easy as just sliding it in to the holder like I've done here. And this is just to kind of demonstrate. This isn't the reason I got it. I just got it just because it was like $45, and it's made in Taiwan, so it's higher quality than your average $25 throwaway Chinese die grinders. So pretty good, and I was able to sharpen up all of my pointers. Works great for that, and I'm sure there's a lot of other things I can use it for too. Alright, so let's get back to tramming. So I made a holder for this indicator, 3/4 rod, 3/8 rod, couple of 1/4 20 holes, really straightforward and simple. And I needed to adjust the gibs on the y-axis before I could start doing anything. As you can see, they're out either way just a little bit, so I got that sorted out, got my gibs adjusted, and then I started working on adjusting the head. Based on the measurements that I took at the beginning of the video, I just translated that to a square at I believe it was 5 5/8, so it would make it easy to do this part of the setup. And here is the reason why I went through all this trouble. This is a real hassle, because as you tighten those bolts, if you watch the indicator needle move, I'm only moving it about 1/1000th of an inch, but every time I tighten one, it moves it one way, and then I tighten the other one, it moves it the other way, which makes it very difficult to get it in alignment. So that's why I went through all this effort. This makes it much easier to do than the way I was doing it before. So now doing an angle or something, I'm not going to be so shy to do it because I don't want to tram the head. So this makes it much easier, and you can see that the reading is very stable. I'm not fighting with the slots on the table. I'm not dealing with a fidgety test indicator, and the resolution of this one is the same as the test indicator, so it's all good there. Very happy with the result, and I did check this against the table itself without the disc just to verify that the disc wasn't off, and I'm all good. So I learned a few things on this project, and one of them is that when you want to make something really accurate, you need mass. Because I tried to make a tramming ring out of what I thought was a more appropriate piece of material, but it was made out of stainless. It was much too thin, it's too large a diameter, too chattery, too hard, too difficult to work with. Just didn't work out. It needs to be surface ground to be accurate. It's a perfectly acceptable part. It's within 1/1000th, but it's not good enough for what I wanted to do with it. Thanks for watching.